Oh, exercise 5e. Now this is a topic of direct and inverse proportion. Now I'm hoping you've done quite a lot of this at GCSE, and certainly in the past I haven't tended to teach much of it. Now it's on the new, it's specifically stated on the new specification for the new A-level. So obviously I'm teaching it, but I'm hoping most of this is going to be fairly straightforward. You know what's going on, and well, who knows? Let's see. Now first of all, direct proportionality. Like this happens, for instance, when you might have an example. It's like it might be something just fairly straightforward, like I buy a book and it costs £4. How much will 10 books cost? Well, it's not hard to work out. It's 10 times as much, and you kind of get a formula there that would the cost would be 4 times the number of books that I buy, and you can quite easily say that C is proportional to B. The cost is proportional to how many books I buy. And that's really what all this is. Interestingly, you get a straight line graph when you get these. It's described as a linear function, if you like. It doesn't have to be always linear. If I get some weird proportionality, it might be, for instance, that I'll say X is proportional to some weird letter P squared, and well, you just got to be aware, how to make that linear graph, I suppose. And inversely proportional, the standard example I was always told as a child was that you had like 4 men would dig in a ditch, and it'd take them 10 days to dig the ditch. Now, obviously, if I had more men available, or women, I suppose, in these modern times, if I had more people to dig this ditch, it would take less time. So 1 goes up. The more people I have, the time, so if people increases, I think the time should decrease. It won't take as long with more people to do it. And this is called inverse proportionality. The example I just gave is the number of people required is inversely proportional to the time it will take to do it. Or I could have said it the other way around. And this gets an equation y equals k over x. And notice this reciprocal graph, because this is really a reciprocal function. This reciprocal inverse proportionality graph is curved. And it can even be curved over here, because as we've seen recently, that the 1 over x graph has 2 parts to it. So after that long description of what we're doing, let's do a quick start to write down the equations for these graphs. I want you to pause the video and see if you can write down the equations without cheating. Just have a go at it. If you get them wrong, get them wrong, but see if you can remember what they are. So pause the video. Okay, I hope you did pause the video. I hope you have got all of these questions, well, at least an equation written down of what you think it is. Let me just run through what I think it is. The equation is y equals x cubed. The standard x cubed graph. This is y equals 1 over x. And I should point out, if you haven't written y equals, you've lost a mark already. You're meant to write the equation, and if you don't write y equals, it's not a very good equation. Now this is, no, I don't know, it's y equals 2x or y equals x. Y equals 48x, all I care, as long as it's y equals so many x, and I'll let you get away with 1. But it's a positive number, so if you've written y equals minus 2x, no mark. Now this is one that you probably haven't seen. This is actually, I think, y equals 2 to the x, but it's an exponential graph. So if you didn't get that, fair enough. This is called an exponential graph, and we'll definitely need to be able to see it. You might have seen it already. This is an equation. Now again, what is it? It's a straight line graph, so it's y equals mx plus c type scenario. And really I wanted you to make up some numbers. It seems to cross at 2. So I'm going to say y equals x plus 2, but you could have said 3x plus 2 for all I care. It just needs to be a set number of x plus a number. And if that is crossing at 2, then it's definitely y equals so many x plus 2. This you should have known is y equals x squared. This looks like y equals x squared, and it seems to cross there at 2 again. So I think it's x squared plus 2, and this one we've seen recently is 1 over x squared. And if you've written 4 over x squared, for instance, likewise here, you've written y equals 3 over x. Who knows? It could be right as well. So don't worry about what the number is on the top. Personally, I'd always write 1. Direct proportion then. So if 2 quantities A and B are said to be in direct proportion, then we can write that as A is proportional to B. but we can straight away write that as an equation, and the k is called the constant of proportionality. Now, I don't know why I've gone with this graphic of from autograph, but basically it doesn't matter what it will be a straight line. So yeah, just be aware the graph you get from this situation should be a straight line, and its gradient should be k. So if I was to plot some points and work out its gradient, well, that would automatically tell me what k is. And to find k, if we've got the numbers themselves, we can just divide it. Notice, just rearranging this equation does this. So a equals kb, move the b over, a divided by the b will equal the k, and that's really what I've said. A divided by b equals the k. So here's an example. A is directly proportional to the cube of b. I've immediately tried to confuse you. A is proportional to the cube of b. Notice that changes things. Write the equation. A equals k times b cubed. And our job is to work out k. Now they usually give you two pieces of information about a, one letter and the other letter, and you can see there they have. They've said a is 240 equals k times, notice it is a times, there's no letter in between, b cubed. What was b? B was 4 cubed. Well, no, 4 cubed is 64, so 240 equals 64k. So k, lost my pen, let me just get my pen back. So k is obviously, it's the 240 divided by the 64. And we'll just do that on the calculator. 240 divided by 64 equals 15 over 4. Now you can probably just write that better, can't you? You can just write it as a decimal, I suppose, is better. 3.75. Just because it's a nicer number to have in an equation, I think. So what is my equation? My equation actually says a equals, it was kb cubed, it's actually now 3.75 b cubed. Okay. So I haven't even started answering the questions yet. I needed that though to get my k, so now I can do part A. My part A says find A when B is 6, so it's quite straightforward. A equals 3.75 times 6 cubed. See what that is. Times by 6 cubed, 810. So very simple once you get to that stage. What does B say? B says find B when A is 150. So it's the other way around. A is 150. And just going back into this equation, equals 3.75 times by the B cubed. So presumably B cubed is 150 shared by 3.75. Let's do that. 150 divided by 3.75, 40. So B must therefore be the cube root of 40. Don't forget to cube root it then. B equals the cube root of the answer is 3.42, I get. 3.42. And sketch the graph. Now the graph of this, so see. The graph is just, it's a cubic graph. That's basically, and we've seen a cubic graph before. Looks like that. Now, the fact that it's 3.75 times by b cubed really doesn't make any difference. It's just, that's A, that's B. I'm not putting any scales on anyway, so it's just been stretched upwards, stretched downwards. And that's what it is. So that's my graph, 8, 10, 3.40. So that, yeah, it all works perfectly. Okay, I like that. So the next question is all about inverse proportion. Now, I mentioned this at the start. Inverse proportion is as one gets bigger, the other gets smaller. So if you're told that two things are inversely proportional, we usually write that as A is proportional to 1 over B. And you should have seen this at GCSE. We can write it as an equation as A equals K over B. Notice the K just gets put on the top instead of the 1. And again, K is called the constant of proportionality. Now this time you can quite easily see, if I move that over, K is equal to A times the B. So you end up multiplying two things together to get the K. Graphically, this is the reciprocal graph again. And that's what I was saying. To find it, you find the product, you times one by the other. So let's do a question. Y is inversely proportional to the square root of x. It's the harder ones at A level, isn't it? It's not just the inversely proportional, it's inversely proportional to the square root of it. So is y equals, well, I suppose technically I should write y equals 1 over the square root of x. And therefore y equals k over the square root of x. And it's given me two numbers again. You're always looking for these two numbers which kind of correspond to each other. Y is 10. 10 equals k over root, well, x is 2, so root 2. So that moves over, and I get k equals 10 root 2. Now, that isn't a nice number, so I'm just going to leave it like that. My equation then becomes y equals k. Now, of course, k I now know, so I don't know why I wrote that. 10 root 2 over the square root of x. That's my equation. It's not very nice. But it says find y when x is 3.5. So part A, y equals 10 root 2 divided by the square root of 3.5. And I don't think this is going to get very nice, so I'm just going to do it as a decimal. 10 root 2 divided by the square root of, was it 3.5? And I get 7.56 to 366. 7.56. See in a bit if that's right. B, what's it say? Find x when y is 5. So it's again, you just move that over. So if I move that there, and the y is going to switch back again, I'm going to write root x equals 10 root 2 over y. So what's it say y is? Y is 5. So root x, therefore, root x is 10 root 2 over 5. Let's work that out. 10 divided by root 2. It's not 10 divided by 2, it's 10 times by root 2. And then I divide by 5. I've got 2 root 2, and that's 2.83, allowing for a bit of rounding error. Root x equals 2.83. Now leaving that whole number on, notice the square root has got to move on to the other side. X is 2.83 squared. I shall use the proper number, not the 2.83. I get exactly 8. Probably should have known that because that was 2 root 2. Sketch the graph. The graph of this, I'm just going to draw it down here. Now, it's my equation is this. It's some horrible number over root x. It's not obvious, is it, what that looks like? I think that, to be honest, is a bit mean of them, so I'm going to cheat. I don't know, so therefore I'm not really expecting you to know. There it is. I wouldn't have known that that was the graph. So I don't think that necessarily will come up quite like that. It'll be easier graphs. Did I get the other two right? 7.56 and 8. Yes, I did. Look, in class we're going to do an exercise. These are the questions we're going to start playing around with, but very quickly we'll have finished. And we will go on to the textbook exercise 5e. So we'll just see how much we can get on and through those kind of questions. We might concentrate more on the textbook and less than might be the exercise. We'll see how it goes, see which one I think is best. And other than that, I think that's fairly straightforward and we can do that. So thank you very much.